And then I have some comments. You can ask questions. And then I will do some of the questions in your assignment, in the assignment that I gave you yesterday. So let me look at the last test first. Test. Okay. So in the last test, so first of all, there are some formulas such as these two formulas for the cosine and sine of the double angle that are very useful in general. So we know that, for example, sine of 2x is 2 times sine x cosine x, and cosine of 2x is cos square x minus sine square x, right? And remember that you can also rewrite this in other form, like this: sine x equal to 2 times sine x half cosine of x half, and cosine of x is cosine square of x half minus sine square of x half, right? For example, in question 7D in your test, you want to prove this identity. Tangent of x half equal to 1 minus cosine x divided by sine x. So here I can work on the right-hand side. So here the right-hand side equal to, so let's use this formula. For cos x, we have cos square of x half minus sine square of x half. But I know this is equal to, also equal to 1 minus 2 times sine square of x half, right? So the right-hand side is equal to 1 minus cos x, which is 1 minus 2 times sine square of x half, divided by sine x. What is sine x? I can write it as 2 times sine x half cos x half, right? So on the top, you have 1 minus 1, it's just 0. So 1 minus, you have minus 2, so it's 2 times sine square of x half divided by 2 times sine x half cos x half, which is equal to, if you simplify this, you get sine x half on the top divided by cos x half, right? Which is exactly the left-hand side. That is the tangent of x half. No, it's left side, it's not clear how to proceed, but from the right side, it's better. Okay, is that clear? Or question 7a. So in 7a, you have to prove that tangent of pi over 4 minus x half equals secant x minus tan x. Again, remember that tangent of alpha minus beta, or is equal to tangent alpha minus tangent beta divided by 1 plus tangent of alpha times tangent of beta. So the left-hand side equal to tangent of pi over 4 minus tangent of x half divided by 1 plus tangent of pi over 4 times tangent of x half. But tangent of pi over 4 is just 1. So you have 1 minus tangent of x half divided by 1 plus tangent of x half. So here, what you can do is, yeah, so you can write this as 1 minus sine x half divided by cos x half over 1 plus sine x half divided by cos x. So this is equal to, if you multiplied both numerator and denominator by cos x half, you get cos x half minus sine x half divided by cos x half plus sine x half. So you have this, right? Now what you can do is to multiply this guy by cos x half minus sine x half. But you also need, when you multiply by something, you need to divide by the same thing. So on the top, you have cos x half minus sine x half squared. And then at the bottom, you have cos squared x half minus sine squared of x half. Cos squared x half minus sine squared x half, which is cos x, right? You see here, cos squared of x half minus sine squared of x half is just cos x. So on the bottom, you have just, this is just cos x. But what about on the top? On the top, you have cos square of x half plus sine square of x half minus 2 times sine x half cos x half. or maybe let me write it in another line. So this is equal to, on the top, you have cos square of x half plus sine square of x half minus 2 times sine x half cos x half divided by cos x, right? But sine square plus cos square is just 1. Therefore, you have, and 2 times sine x half cos x half is what? Can you tell me what is 2 times sine x half times cosine x half? Sine of x. Therefore, you get 1 minus sine x over cos x. Perfect. This is nothing but secant x minus tangent x. Because secant is 1 over cos, tangent is sine over cos. So let me explain a little bit about question 6. Question 6, it says that you have to solve this inequality. Solve for x. 2 times cos x plus 1 greater than 0. Solve it, and x is in this interval, 0 to 4 pi. Let's look at, so that means here, you must have cos x greater than minus 1/2, right? So let's look at the graph of cos x. You want to find the values of cos x that are greater than minus 1/2. Let's take a look at the graph of cos x. On the interval from 0 to 4 pi. So at 0, the value of cos x is 1. And then it goes to pi half, 3 pi, maybe a little bit smaller. So this is pi half, 3 pi half, 5 pi half, 7 pi half, that is 4 pi. So you want cos x be greater than minus 1/2. So minus 1/2 is like here. So that means x must be in this interval. So look at those regions that are above minus 1/2. Above minus 1/2 means this region, and this region. So now what are the x values here? So the first x value is what? Cosine of what angle is -1/2? -1/2. 120, right? 120. So this is 120. As I said, it's better to think in terms of radians. In more advanced mathematics, we don't use degrees anymore. So 120 is 2 pi over 3, right? And then you have this value, which is 4 pi over 3. And then you add 2 pi. 2 pi plus 2 pi over 3. So you get 8 pi over 3. And then here, oh, sorry. Um, 6 plus, you have 10 pi over 3. That's it. So that means x must be in what intervals? X is in these intervals from 0 to 2 pi over 3, union with 4 pi over 3 to 8 pi over 3. Yes. Union with 10 pi over 3 to 4 pi. Right? So that is the first region. This is the second region, and that is the third.
So you added 2 pi, then you add 4 pi, right?
You add 2 pi to 2 pi over 3, you get 8 pi over 3. 2 pi plus 4 pi over 3 is 10 pi over 3. So you look at the region which is above this line -1/2, right? Is that clear from this picture?
Yeah. Unit pi minus 2 pi over 3 is 4 pi over 3.
No, 4 pi over 3. So let me tell you, 2 pi over 3 is 2 pi over 3 is just pi minus pi over 3. And 4 pi over 3 is pi plus pi over 3. So cos of both of them is -1/2. So pi plus pi over 3 and pi minus pi over 3 for both, cosine is -1. Okay, so now for the other one, other inequality, it says that tangent between -1 and 1. Tangent between -1 and 1. Tangent of x between -1 and 1, and x belongs to 0 to 4 pi. So now let's take a look at the graph of tangent from 0 to 4 pi. So tangent has some vertical asymptotes at pi half, 3 pi half, 5 pi half, and 7 pi half. Maybe, sorry, let me just draw something smaller. So the first asymptote is x equal to pi half, x equal to 5 pi half, sorry, 3 pi half, and then x equal to 5 pi half, x equal to 7 pi half. And you also pi half, then you have, this is pi, 3 pi, no, not 3 pi, what? So the graph of tangent is like this. Now we are looking for those values of tangent that are between 1 and -1. So let's say 1 is x equal to y equal to 1. Let's say this is y equals to 1. And the other line, y equal to -1. So what region I'm looking at? I'm looking at this region. Let me highlight this region, this region, this region, this region, and this region. Between -1 and 1. Right? So this point is pi over 4. This point is 3 pi over 4. This point is 5 pi over 4. And so on. This one is 3 pi, 7 pi over 4. And then you get 9 pi over 4, right? So that means x must be in 0 to pi over 4. And then from 3 pi over 4 to 5 pi over 4. And then from 7 pi over 4 to 9 pi over 4. And then from 11 pi over 4 to 13 pi over 4. 11, 13. And then the last one is 15 pi over 4 to 4 pi. So, but you have to include 0 and 4 pi. Yes. No, because we begin from 0. You don't look at.
Oh, this is exceeding.
Yeah. Yeah. You begin from 0 and end at 4 pi. Is this clear? Maggie? Liana? Alex? Jeffrey? Michelle? Okay. Now let me give some hint for this assignment, maybe. So the first question, instantaneous rate of change. Let me do 1D for you. Maybe it's some computations a little bit messy. So this one. So I want to compute the limit of f of x plus h minus f of x over h when h goes to 0. Now, what is f of x plus h? It's just x plus h plus 1 over 2 times x plus h minus 1 minus f of x, which is x plus 1 over 2x minus 1 divided by h, right? So then, which is limit of h goes to 0. If you take a common denominator as 2 times x plus h minus 1 times 2x minus 1, then you also have h at the bottom. So on the top, you get x plus h plus 1 times 2x minus 1 minus x plus 1 times 2 times x plus h minus. Okay, now on the top you have 2x squared. So the first bracket, let me just write the first bracket. So you have 2x squared and minus x 2x squared plus 2x minus x is just plus x. I simplify at the same time, so you think about this. So 2x squared plus 2x, and then you have minus x, and then you have 2xh. And then you have minus h minus 1, right? minus, and so, and here, see that the first two terms are just 2x plus 2h, right? So you have x plus 1 times 2x plus 2h minus 1. So that is going to be first 2x squared, and then 2xh, and then you have 2x minus x, which is plus x, and then you have 2h minus 1. And then divided by the same thing. 2x plus 2h minus 1 times 2x minus 1. So you have 2x squared. No, not 2x squared. So 'right? Okay, now what you have is on the top, 2x squared minus 2x squared, they cancel each other, and then x minus x, they cancel each other. So the only term that remains is you have minus h minus 2h, so you get minus 3h divided by h times, or maybe that, just let me write it like this, 2x minus 1 plus 2h times 2x minus 1 times h, right? Very good, I like this. Now you can cancel out h, so you can cross out h. So what you get is the limit when h goes to 0. On the top, you have minus 3. At the bottom, you have 2x minus 1 plus 2h times 2x minus 1, right? Now, when h goes to 0, this guy becomes 0, right? So you get minus 3 divided by 2x minus 1 squared. Magic. Is that clear? So in your calculus, you're going to see that this is nothing but the derivative of this function, f of x. This is 2x. Okay. Do you have any other questions about this last assignment? Oh, question 4. No, it's a challenge for you. Other than 4. So by the way, 3b, so when I say some absolute value of some t equal to t, means t must be positive. So when you say that absolute value of t equals to t, it means t is greater than or equal to 0, right? So that means this is basically an inequality. So x minus 1 over x plus 1 must be positive. But I'm not sure about your last answer, but that's something you have to do, yes. So I think your last answer is not, can I see? What is that, your answer? What it means here? X greater than 1?
Or equal.
So no, x greater than 1, less than negative 1. You cannot write like this.
I have to write separately?
Separately. You write this when x is between two values. But here, x is greater than or less than this.
Oh, okay.
And this, basically, the way you wrote is not correct.
Okay, good.
Okay.
So x can be greater or equal to 1, right?
And, or, you have to write them separately. Okay. You should tell me what is the answer. You are supposed to do. Which one you mean?
X bigger and equal to 1, and then x smaller than
That makes sense.
is correct.
Yes. Okay, any other question from this? So something that I should tell you is so imagine, so I'm going to go over some sample final exam, which is on the website. So, for example, look at the sample exam. Let me see if I can open it in my iPad.
Where? In the online?
What website? Yeah, is at the very end of the website.
I know the sample 1 and 2.
Yes. Sample. Okay, so let me.
There's 20 pages.
told me to show civilian how much practice. $12,000. I think probably they make them just like well.
Okay, so look at this one of the sample. I think it's the sample exam 2, the second sample. So question 1, it says that solve the following question about polynomials. So it says the polynomial 12x cubed plus kx squared minus x minus 6 has 2x minus 1 as one of its factors. So that means here, this guy, 12x cubed plus kx squared minus x minus 6 is equal to 2x minus 1 times something that we don't know. Let's say times qx. Doesn't matter. Here, you just we want to find k. It's quite easy. So let x be equal to 1/2, right? Because when you let equal to 1/2, on the right-hand side, you get 0. On the right hand side, 2 times the 1/2 minus 1 is just 0. And then on the left hand side, you get 12 times 1/8 plus k over 4 minus 1/2 minus 6 equals 0, right? Then you can find k. Is that clear?
Is equal to. Why is it equal to 0?
Because when x is 1/2, the right hand side is 0, right? Look at the first equation. When x is equal to 1/2, the right hand side is 0, right? 2x minus 1. Now for the part B, you're looking for a quintic means of degree 5. So you're looking for a polynomial of degree 5. So that means p of x is equal to. So first of all, it crosses the origin. So that means you have a times x, because it crosses the origin. And then you have 2 turning points at -5 and 0 and 4, 0. So you have x plus 5 square, x minus 5 square.
This type of question, we've never done it. Style.
Okay, so these are the factors. So, but the only thing is, what is the value of a? So we know that it crosses the point 10 and 10. So that means p of 10 must be equal to 10. So you let x equal to 10. So a times 10 times 15 square times 6 square must be equal to 10. Then you can compute a.
Why is it x plus 5 squared?
Because it says that 2 turning points at -5, 0. That means it's a factor of degree 2.
So the turning point is what?
Means basically zeros. So if you have a yes, x-intercept, roots or zeros.
So we only use these two turning.
I use the turning points. One is -5 and one is 4. So you have x plus 5 and then x minus 4, but the degree is 2. And if you want to draw the graph of a polynomial, it's in the factored form. So Let me tell you how to draw the graph of a polynomial which is in the factored form. So here you have three roots. One is -2, one is 1, and then 2. These are the three roots. So because it's x minus 2 to the power 3, so it goes like this here. And the reason is when you have something like x minus 1 square, if it's a square, if it's x minus 1 square, then it's either for a square, it crosses the x-axis. Oh, sorry. If it's an even power, if the power is even, it crosses the x-axis either like this or like this for even powers. Even powers crosses the x-axis like this. But for odd powers, except that one, it crosses either like this or like this.
Oh, it is breaking back.
And if the power is 1, then it either cross like this or like this. And this is the same as odd powers, but if it's greater than 1, it really gets very close. So we say it's tangent to the x-axis. But never mind, so you don't need to be worried about this fine details. So remember that for even power, you cross the x-axis like this. For odd powers, like this.
For odd powers other than 1, the curve looks more like this, right?
Yeah, so it's tangent at x at the x-axis. Oh, sorry, it's x plus 2 square. So this, I made a mistake. I thought it's x plus 2 cubed. So it's x plus 2 square. So x plus 2, again, is an even power, right? So that means it goes like this.
How do you determine the direction?
That's a good question. So you determine by looking at whether it's going positive or negative. If x is greater than 2, the values are all positive, right? If x is greater than 2, so it goes up. If x is less than 2, it must be negative. So it cannot go up again. So this function, p of x, that's a good question. This function, so the sign only depends on the last term because the first two terms are always positive. So if x is greater than 2, then p is positive. If x is less than 2, p is negative. I mean, and then the graph of this is easy. It's a rational function, so you should know what is the horizontal asymptote. What is the horizontal asymptote? X 1/2, right? Y equal to 1/2. What is the vertical asymptote? X equal to, so vertical is X equal to something. -5/2. And then once you have the horizontal and vertical asymptote, you can draw the graph, right? Y equal to 1/2. Y equal to 1/2, something like this. And X equal to -5/2. So this is X equal to -5/2. So when X is close to -5/2, so for example, X close to -1, so the value is negative. So that means the graph goes like this. And what is the y-intercept? Y-intercept is equal to, when X is 0, Y is -2. So the y-intercept is Y equal to -2. What is the x-intercept? X equal to 10. These are, it's good, helpful to indicate the xy intercept, right? And then C is a straightforward. You just do a bunch of transformation. So that means you have to solve, but you have to be careful when you solve, you find X, because you have logarithm here. So logarithm of X -1 means when you solve, you must make sure that X at the end must be greater than 1. Or X must be greater than -2. But this is enough. When you say X greater than 1, it would be greater than -2, right? Because otherwise log of X -1 doesn't make sense. So for example, if you find X equal to -5, then log of -5 -1 doesn't exist. So you have to make sure at the end that X is greater than 1. And here it's easy to solve because you have log of X -1 times X plus 2 equal to 1, right? That means X -1 times X plus 2 must be equal to 10. So you solve this, but be careful that at the end, your answer must be greater than 1.
So like X is positive.
Greater than 1, not only positive, but greater than 1.
I mean, like if you sub X in, that the value has to be positive.
Positive and greater than 1. It's more than positive. So for example, 1/2 is a positive number, but it's not greater than 1.
So log of something has to be greater
So
than
you
1.
need to.
No, I mean x, you solve some equation. It's a quadratic equation. You just solve, it's like grade 10 math. You solve equation, but at the end you have to check, is x greater than 1? Your solution, is it greater than 1 or no?
So you need to slow these equations and find some answers is bigger than.
Yeah.
So I'm saying like, if x wasn't greater than 1, then. it
There is
would
no
make-
solution.
Yeah, it would make the whole thing negative, right?
There is
Yeah.
no solution.
So the log of x, the whole equation has to be positive, so that's why x would be greater than 1. That's what I meant. I mean,
Yes.
whatever, that's.
Yeah. So the condition is x greater than 1. Yeah, or the next question is just 1/3 times log of this guy is equal to 2/3. That means, oh sorry, 48x. So that means, again, you have to be careful that whatever answer you find at the end, x squared plus 48x must be positive. That's the condition. So that means x squared plus 48x must be equal to what? Can you tell me? Is equal to what? You say log of something is equal to 2. That means if log of something is 2 and the base is 10, that means x squared plus 48x must be 100. That's it. So here, for the question 4, you average rate of change is easy. Average rate of change, let me write average rate of change is just f of x plus h minus f of x over h, right? So here is during the first 10 seconds. Basically, it means f of 10 minus f of 0, so divided by 10. So, and x is 0. Oh, sorry, 10. Sorry, t. Here you have t, not x.
Average rate of change x2 minus x1 over x2 minus x1.
Yeah, that's the same thing. So here x1 is 0, x2 is 10. So t is at t equal to 0. But for the for the instantaneous rate of change, you have to compute this limit. Limit of f of t plus h minus f of t over h when h goes to 0. So this is the instantaneous rate of change. So you find that something in terms of t, and at the end you have to let t equal to 10. So you compute the instantaneous rate of change when t is equal to 10. Or you can, at the beginning, you just, instead of t, you can just plug 10. So that means when t equal to 10, the instantaneous rate of change is just the limit of f of 10 plus h minus f of 10 divided by h goes to 0. So you have to compute this expression, this limit when h goes to 0. So you have to find basically a number. So there is no t here. In the examples that I did before, we did like generally at any x or any t, but here t is specified, is a specific at t equal to 10. Okay, so so here let me tell you the difference. When you have a function f of x or whatever, f of t, if they say find the instantaneous rate of change at x equal to something, at x equal to a, for example, here x equal to 10. What you want to compute, you have to compute is f of a plus h minus f of a divided by h, the limit h goes to 0. If I don't specify any particular number, you just plug x, f of x plus h minus f of x divided by h. So I want you to work on these problems just for yourself to practice. And then you can ask me if you have any question, I'm here. Okay, after the lunch, I'm going to mark your tests. Your final exam, Monday or Friday? Friday, right? Then you can have a nice weekend.
No.
Think about it.
A nice weekend is for the study.
You can enjoy your weekend.
Oh, she can have it on Friday, we can have it on Monday.
Let's do it on Friday.
No. We're having a practice. I feel like.
Do it.
Yeah.
Then enjoy your weekend.
It's gonna make me depressed if I don't do good on my test. I'm gonna have a depressed weekend. I feel like, oh, I have my time to study.
Depressed weekend is better than stressed.
No, it's more stress these days. I'll have like mental breakdown.
Damn it.
See you on Monday.
You said you cannot do on Monday? You're leaving on Saturday. Okay. How about others? Next week, Monday?
Next week, Monday, no. School starts September the 5th. The 6th, and that's next Wednesday.
So you can tell their school.
中午节就开学了，
真的呀。
Okay, so anyway, so yes, it's hard to do it on 2 days because let's do it on Friday. It's today and tomorrow you work hard.
The first semester is on Tuesday, so Monday is fine.
But Friday you can come afternoon. It's the time. I don't have any restriction for the time. Okay,
What do you mean, come on, Jimmy?
you can come. You can write your exam at 2 or at 1.
The school closes at 4.
Yeah.
It's only 4 hours.
Do you need more time? 4 hours?
How many times how long do we get for the exam?
About 2 hours.
2 hours?
Yes.
2 hours.
How many pages?
I don't know. I didn't
You will
print
have
your
a, you
exam.
will have formula sheet.
No, but no formula. Yeah, so for formula sheet, you can have 1 page,
Oh,
just one. You can bring 1 page with yourself. Whatever you want, you can write it on, but only 1 page,
Front and back.
Hmm?
Front and back.
front and back. Okay, and you can write anything you want on 1 page. Happy, Angel?
so our task is taking the Friday, right? So our final exam is the Friday.
In Friday. Good.
Can we choose Friday or Monday?
Okay.
Let me think about it.
Amen.
But you can do it on Friday, you too. Okay? So tomorrow is our last day. So I want you to go over these 2 sample questions and we can discuss if you have any question tomorrow.
There's 2 sample exams.
Yes.
The other one is like 20.
Yes. And then for the final, if you want to get prepared, also look at your assignments and your tests.
What?
The tests that you have so far. Okay? So the questions are going to be similar to the tests, assignments that I gave you so far.